Hello, everybody. It's time for another edition of WAVY Science Lab. I am the host, meteorologist Jeremy Wheeler, and today we're going to be talking about something very simple. We're going to be talking about the moon. Lots of folks maybe know a lot about it. Maybe lots of folks don't know much about it. It's hard to know. It's not made of cheese. I'll tell you that right now. At least that's what I heard. Yeah, no, we're gonna get into the science of it and talk about it a little bit, and actually quite a bit, and see some really cool imagery too from NASA. So let's do that, and let's get into it, and let's talk about the moon. So the moon is a bright object in the sky at night. It is really something to see, especially when you got a full moon, or sometimes you get the eclipse, the lunar eclipse, things like that. And we're going to talk all about that. So the moon by itself is really neat. It was formed about 4.5 billion years ago, give or take a year. And it's a large object, actually, the size of Mars, collided with the Earth and hit the moon. And when that happened, then it created this, well, a lot of debris, basically. I feel like it hit a blob like a lava lamp, and then it bubbled off. But actually, the theory is that a lot of debris came about, molten, and debris collected that. And it was around the moon. And there's an artist rendering of it. Of course, there was nobody around at the time, but there's an artist rendering from NASA of what it looked like. Again, some large object hit the moon and then bounced off and went somewhere. I'm not exactly sure if they know where that actually went, but then after that, all that debris collected and then formed the moon due to gravity and heating, and so that happened over a period of time. And so, the previous thought is that the moon was captured by gravity. Hey, gotcha, but that wasn't the case. After time, the Apollo missions changed the understanding of this, and so back it up a little bit. So pardon me, I am clicking the wrong thing here. Okay, so the Apollo missions, here we go. They brought back a whole bunch of pieces of the moon, 842 pounds of samples. The age of the moon about 60 million years after the solar system started. So what happened was they did a whole bunch of research on all these samples, and they found that the chemical makeup of the Earth and moon rocks were very, very similar, too similar to be coincidence. So the moon was once covered in an ocean of magma, hot magma. Remember that from Austin Powers back in the day? Sorry, some of you are like, what? Some of you are like, oh, yeah. Yeah, that was great back in the day. Anyway, so the lava flowed up the moon's crust and filled in a bunch of impact basins, and we're going to talk a little more about that in a little bit. But yeah, I mean, they figured out that, the theory, current theory, is probably what happened. The impact, and then the creation of the moon after that. Lunar soil is made up of pulverized rock from meteorite impacts. I mean, just billions of years of meteorites just smashing into the moon and then creating all that dust and debris. So that added up over time. So this is a cross section of the moon, and we're going to go into the layers of the moon. And this, again, also from JPL, NASA. So there's a whole bunch of different pieces of it. And some folks may not even realize that there is a core in there, but there is. And so that's the beginning of it. Let's go into that. The inner core is all iron, the temperature about 1,600 to 1,700 degrees Kelvin. And we talked about that in the temperature. Kelvin is a unit of measure for temperature. It's basically add 273 degrees to the Celsius, and that'll give you the Kelvin temperature. Keeps it so they didn't have to deal with negative numbers so much. So anyway, 300 miles, and there's other reasons. 300 miles in diameter for just the inner core itself, and so the bright yellow and orange on the graphic. So again, right there in the middle, that bright orange, that is the inner core. So then there's an outer core, which is kind of the darker red, I believe. And so that's mostly molten iron, some nickel, some sulfur, and it goes 410 miles in diameter. So that's the diameter of the outer core. The density, 2.9 ounces per cubic inch. Okay, well, I got that number, and I'm like, well, what does that mean? I mean, that sounds pretty dense to me. So I use Google, and I got the water is 0.578. So it's much more dense than water, of course, but by quite a bit. And so this density, it's just a hard molten, mostly molten iron core, and that's the outer core. So now we go into the lower mantle, and we've heard these names before when it comes to Earth, right? The mantle, the crust, things like that. So the lower mantle partially melted, and the thickness is 93 miles. But there's more. So then there's the upper and middle mantle. Okay, all right. Well, this one's fully solid though. The other one is partially melted. This one's fully solid. Extends from about 31 to 190 miles below the surface of the moon. And then the lunar quakes originate there. Didn't know that. Very interesting. And the moon does have quakes. So then there's the crust. The thickness is about 31 miles. And wow, that sounds like a lot, but it really isn't when you think about, the thickness of the moon in relation. The far side is 10 miles thinner than the Earth side. Wow, I did not know that. That was something I think they might have found out recently, somewhat recently. But yeah, so it's a little thicker on one side than the other for the crust. Very cool. Not graham cracker, graham cracker crust. Oh boy. All right, so let's take a look at the kind of comparative to the Earth. And so here it is, and this also from NASA. And the size comparison on the left, you can see, the outer core there is bigger than the entire moon. The outer core of the Earth is bigger than the entire moon. So that's pretty, I think the inner core is, well, it's still smaller. But proportional, when you got it on the right side, you can see the proportion of the crust and the outer core of the mantle compared to the Earth. Of course, it's not the same size, right? But you can see that there's the crust plays, it is thicker compared to the diameter of the moon compared to relatively the Earth. The Earth, I think there's one little thin line there on the outside, and that represents the crust. So yeah, it's just so small compared to the diameter of the Earth, and that's neat. I mean, that's really something to see when you look at it like that. So I'm glad that NASA, did that and put that out there. So let's move on to the next thing. We're going to have to take a break here in a moment. But the surface of the moon. So the light areas are the highlands. I thought I saw somewhere that was Terra, and then the flat dark areas are the Maria, which is Latin for seas, and the areas where the lava bubbled up and cooled. And then you have the craters from meteorite impacts. Okay, so that's kind of the moon. We're going to go more into this coming up in just a little bit. Stay with us. All right, we are back, and so we covered a whole bunch of cool stuff just a moment ago, and now I want to show you some of the imagery from that. We talked about the surface of the moon and different parts, but I want to show you what the surface looks like there. So we talked about the highlands in light colors, the higher elevations, the kind of darker areas, they're the Maria, and then you've got the craters as well. So that's the surface of the moon. All right, now let's take a look at the moon-sun distance, some things all relative. So the sun diameter, look at that, 860,000 miles. The diameter, the moon diameter, 2,159 miles. Pretty neat to see. But the sun is so far away compared to the moon in terms of, from the distance from the Earth. And so, that's why relatively they kind of look like they're not too different size-wise. Sometimes maybe, but well, I guess it's the moon. The sun is so much brighter, so I guess it's hard to tell anyway. So we've got the different phases of the moon, and I think most folks are familiar with this. This is the new moon, and it's all dark, but you can see it. It's barely visible, and it kind of depends on the time of day too. But it is visible during the daytime. The moon is in between the sun and the Earth, but different parts of the sky. If it's in the same part, then you get an eclipse, but it's not. It's slightly off. It's maybe a little above or below what we call the ecliptic, the plane where the eclipses happen. Sometimes a little above or below that, and so it is up during the daytime. It's hard to see. So that's the first phase, and so here's the second one: the crescent moon, the canyon of the crescent moon. You know what moon I'm talking about. All right, so the crescent moon, there's a thin sliver showing in this case. And you've got, when it's going and you get increasing light, it's waxing. decreasing light, it's waning. So when it starts off after a new moon, you get the waxing crescent. I think of it like I'm waxing the surfboard and getting ready to go out, and then waning, kind of familiar with waning, the word waning, but waxing, I think of that as, increasing light. We're going out to go surf and get things ready, so it's increasing. That's how I think of it. Maybe I'm a nerd, but well, I am a nerd. But anyway, a big portion of the light side faces away from the Earth in that one. So then the quarter moon, half of the lit side is showing. You think, Jeremy, no, that's a half a moon right there, baby. Yeah, but remember, it's half of a half because you're only seeing half the moon, so it's a quarter moon. You got first quarter, last quarter. So, I tricked you. So there it is, the quarter. Here's the gibbous moon, and the majority of the moon, the lit side is showing in this one, and it's Latin for hump. I did not know that. I always wondered about that, and so yeah, that's where gibbous comes from. And the moon rises later and later each night. And then, of course, you got waxing gibbous and waning gibbous as well. So those are the different moon phases. So you got the full moon. We're all familiar with that one. Very familiar, very pretty. Full moon, entire disk is lit from the sun. And the moon is opposite the sun, and it rises around sunset, sets around sunrise. So those are the different phases. All right, so now we've got some different features. This is the blood moon, right? During the lunar eclipse. Remember the Blade movie, right? You had to wait for the blood moon for the thing to go down. I don't want to go too into detail, but yeah, I mean, sometimes these eclipses, they're harbingers of doom. So only light reaches the moon. The only light is from the Earth's edges, and when that happens, the blue light is scattered, also from dust, haze, and smoke. But when you've got a true bona fide eclipse, a lunar eclipse, that's when you have the light being scattered. And so you got the different shadows. You've got the Earth's penumbra, which this was an eclipse we had maybe last year before. So it might be just a little darker during that, but then it gets really dark during the umbra, the main shadow of the Earth. And then, and then it comes and goes. And so I command this. And yeah, there it is. There's the Earth's umbra right there. And it looks reddish. It does. And then it goes away. So that's a lunar eclipse. And we're not going to go into solar eclipses because we're talking about the moon. So the moon types, you got a super moon. Everybody talks about the super moon. I hate to say it. To me, it's not a big deal. The moon's a slightly bigger, slightly brighter. Sometimes it's impressive. But a lot of times I feel like there's a lot of hype and people go out and think, wow, this thing's going to be, Bruce Almighty. But no, it's just, but it is pretty, even without being a super moon. So, and then during perigee, when the moon is closest to the Earth, because it's not a complete circle when it revolves around the Earth, and it's a bit of an ellipse. So apogee means the moon is the farthest in the orbit. So there it is, and so you've got and I'll put it in full. At the farthest, it's at apogee, and the closest is perigee. And you can see the difference in miles there. So again, it's an ellipse. It's not a circle. Very cool to see, though. All right, so then you got the full moon names. You got the wolf moon. You've got the snow moon, the worm moon, the pink moon. Being dramatic. These to me, I mean, they're fun. They can be fun. I did not look up what a lot of these mean. I could have, but truth be told, I think I kind of had a limited time. So I kind of just went with these for now. But these are the different moons, different times of the year. And some are obvious. I mean, snow moon, February. Yeah, that makes sense. Harvest moon, September. Yeah, farmers, hunters, October. So there's that. But strawberry moon, I didn't look. I don't know if that's when the strawberries get picked. But anyway, you got the different full moon names in there. All right. Now, there's a lot of NASA missions that went to the moon, more than 140 missions. I was impressed by that. I was like, wow, really? But not all manned missions. So there were 9 human missions from 1968 to 1972. And of those, 12 Americans walked on the moon. Awesome. I'm just so glad we got to do that, just for exploration and research. Awesome. And thank you. Thank you to the astronauts that did that. So the early missions were robotic orbiters and landers at first, I think 1950s, 60s. And then And then eventually they had the human missions. But here's some notable ones. Pioneer 4, Lunar Flyby, 1959. Ranger 7, a deliberate impact. Wanted to see, what happened when, the dust got kicked up. And then Surveyor 1, there was a soft landing, 1966. And then the Lunar Orbiter, orbital insertion. So it went into orbit, 1966. And so the Apollo missions, 1968, 1972. Apollo 8 was the first to orbit the moon. So, the astronauts went up there, they just went around it, and then eventually they landed on it. And of course, that was, they actually simulated first. I did not know that. Apollo 10, they simulated a moon landing, so that was neat. And then Apollo 11, there was the moon landing, Neil Armstrong, Buzz Aldrin. So we're going to go into that coming up a little bit more after the break. All right, stay with us. All right, and we're back and talking about the moon. And the moon, so far we've seen some pretty neat things. Talked about how the moon formed, and then we just got talking about some of the missions. So let's talk some more about that. So backing it up, you had the Apollo missions from 1968, 1972, and then the Apollo 8, Apollo 10, Apollo 11, and that was the moon landing. And then Apollo 13, the Tom Hanks movie. A lot of people familiar with that, and the malfunction on the spacecraft, but it's safely returned. And so through the genius of NASA, they got them back. It was not an easy thing to do. Just if you saw the movie, you saw how they, just went through all the motions and then had to get real creative to try and bring the astronauts back. And of course, the Apollo moon landing was just a lot of science in itself. And there was a movie about that one too. Was it First Man? Ryan Gosling. So here's an actual, there's not a movie, there's the actual photo, I believe, from Neil Armstrong taking the picture of Buzz Aldrin in the moon landing in 1969. So this was from NASA, and you can see the link there. And one small step for man, one giant leap for mankind. But I don't know if Buzz said something when he came down. That's interesting. I have to look that up. So the moon landing. And they saw these features up close, got to see, can you imagine just flying over the moon and seeing features like the craters and, just to see the features. And it's, it's all rocky, but at the same time, it's not completely flat. There's flat areas, but there's just a lot of surface features. So I'm going to take it and take a look at, this again. Yeah, that's just so pretty, isn't it? And it's always pretty to see at night, a full moon. So there it is. And you got all those different features there. And then, it looks very smooth there, but then up close, you notice there's mountains and there's valleys and there's, flatlands as well. All right. So, they got to go to the moon and they did some studies. Then, another mission, the Lunar, Reconnaissance Orbiter, LRO 2009, it continually orbits the moon, and it gets features, right? Maps and updates the surface of the moon. And that's important because, we get the details and we put that on our maps of the moon, make those maps. But also, it helped to find reservoirs of water ice, I believe, in some of the craters on the moon, which they didn't think was possible, but then, it found out there was. And it's also going to help future missions, planning, where the astronauts should go, because there are plans to go to the moon. But this is an image from the LRO. And just so neat to see the terrain there. And I forget exactly what the coloring is. It looks maybe like higher and lower terrain, so maybe it's the relief. But I don't think that's makeup, but it could be. It could be. The higher elevations probably are made up of different stuff than the lower. You get the lava that came up and bubbled up. So anyway, the Artemis mission, Artemis 1, there's an unmanned orbit in 2022. And I didn't know that was going to be, I had to say, I didn't know that was going to be unmanned at the time. I don't know if that was put out there, but anyway, that's more news than NASA itself. But Artemis 2, 4 humans are going to orbit the moon, and that timeline has been changing on that, I know. So I'm not going to give a timeline. And also then after that, Artemis 3, there's a planned moon landing with the humans, and so to go back to the moon and study. And that's good. I'm glad we are, because I want to see, maybe they can really dig into some of those areas and some of those craters and look and just send back some awesome video and imagery, which I'm looking forward to. All right, so that's the NASA missions. Now we're talking about the tides, which we had a whole episode on the tides, so I'm not going to go into this one too much. But basically, that the moon, the Earth spins and the moon, revolves around the Earth, and so as the moon goes around the Earth, it attracts the water around it, and so that goes around the Earth as well. You get the high tide twice a day, and then the moon or the sun rather also pulls on that water. So when you get the two to meet up, you get spring tides, like a spring, and then you get the neap tides as well, which is when they're out of phase, 90 degrees. But so the moon and the sun both help to create the tides, but the moon is the main driver of it. And so those are the tides. Now, some folklore. Let's have a little fun here. In ancient Greece, Rome, Selene and Luna. I had studied some Greek mythology, and I'd not heard of Selene in terms of this, but Luna I have heard of. And then the goddess drove the silver chariot across the night sky, and I believe that's the same deity, but just different naming. Because when Rome took over Greece, then at one point, then they kind of changed the naming. And so I don't know if it was that point that the changed it to Artemis or became a new goddess of the hunt, childbirth. And you might be more familiar with that one. And then Japanese culture, the god Tsukuyomi, a cold and distant god. I looked it up. Oh, interesting. And then Norse, there's Mani, pursued by the wolf. So day and night chasing each other, moon and the sun. And if they were to catch each other, then Ragnarok happens. God of War video game, second one, I believe, one of the newer sets. They actually had that in there in the game. So that was pretty neat. All right, and then some superstition. There's higher crime rates and hospital admissions during full moon. I think there's a little something to that. I mean, it may not be the moon itself, just the brightness, and that usually you get a warm summer night and you're out there and you get a full moon. You kind of get a little more energy, don't you? I mean, maybe it's psychological, but I think there's something to that. The jury's still out. Werewolf, one of my faves. Wolfman, old classic. How many wolf movies are there or shows? There was a werewolf in the 1990s. There was the Wolfman. They redid it in the 2000s, and then there's lots of books, movies. Silver Bullet, Stephen King. I read the book, saw the movie. So yeah, thumbs up as far as horror goes. And then Lunar Eclipse, is a harbinger of doom. And bad omens, and that happened. Of course, you get lunar eclipses all the time, but they thought maybe this drought that happened, around that time was caused by the lunar eclipse. Ancient times, they didn't know that, and they didn't know exactly what it was. They made up stories, but they didn't know. So, but those lunar eclipses, I mean, it does get a little ominous. You see a blood moon like that, a big red moon. I mean, and you don't know what's going on. Can you imagine? At least now we know, and we educate the people, which is why I do this podcast. So there you go. All right, so let's finish it off by talking about the environmental tip of the day. I made a simple one: drive less, use less, fuel, less energy, even electricity. I mean, you still got to use it off the grid. Although you can use solar power, yeah, but so mostly gas, especially walk, bike, swim. Maybe not swim, but walk and bike, and you can carpool as well. But it's kind of tough to do in this day and age. We got so many chores, and everybody's got schedules. But try to make less trips to the store. All right, that's it for today. I am meteorologist Jeremy Wheeler, and I hope you learned something today. And I hope you have a good day. And everybody, just keep learning.